It's called symbolic execution. Of course, you're not going to get actual output, right? If you don't have specific values, you're not going to get specific outputs, right? But what you get is the path condition that is written in terms of external values. Okay? Because you do, as you can imagine, those symbols do go through the transformation that you are going to make by executing those statements. And we're going to look at an example. So that's basically what symbolic execution is about, to connect the path condition and to rewrite the terms of external value. So we're going to look at a very, very simple example, okay? Again, I just want to give you the basic idea and see how it works. Is that later going to S? Okay. So, probably. So this other left-hand side will have the code, and right-hand side will have the control group. Very familiar, right? Tri-type. As you can imagine, it's a triangle classification program. You take 3 sides as input. So if you look at this program, it has a very different implementation than what we have seen before. Okay, the same problem, but very different logic. Okay. So the idea, the basic idea is that the 3 sides, first you have to sort the 3 sides, okay, such that A has the smallest value. I think B has the second smallest, well, second largest, and C has the largest value. So the idea is this: when you take 3 sides as inputs, you first put them into order. Why you want to do that? It's because after you put them into order, the check is much simpler. Okay? So like for example, like the first check, the inequality, like the straight line has to be the shortest. Okay? Remember, if you recall what we had before, you have to check A plus C. Whether A plus C is smaller than or equal to B. You have to check B plus C, right? But now, after the 3 sides are sorted, you know C is the biggest. You don't have to check. You don't have to check A plus C. Okay? You only need to check one of them. I hope you get the idea. Okay? And I also want to use this as an example to show that the same problem we could have very different ways to solve the same problem. That also simplify other checks, okay, after you sort the 3 sides. So let's say what we want to exercise is this part, okay? 1, 5, 9, 10, 11, 12, 13, 14. So I want to execute statement 1, okay, which means this condition has to be false. Okay? Statement 5, and then 9, and then 10, 11, 12, 13, 14. That's the path I want to exercise. To exercise this path, what really you have to do is that you have to make sure this condition is false, this condition is false, and this condition is true. Right? And that's basically what you have to make sure if you want to exercise this particular path. So what we're going to do is that we're going to assign the 3 sides, okay, with 3 symbols, okay, not particular values. We're going to have I, J, K, okay, for the 3 input values. And then say how we're going to execute the program with the 3 symbols. Okay. So let's do that like step by step. So when we execute the program with the with the three inputs, symbolic inputs. So we come to node 1, we're going to check basically now A is I, right? B is J. Okay. So you want to make sure this condition is false. Okay. So what we get is that you just connect the branching condition. You know I has to be smaller than equal to J if you want to execute this one. Okay. Then you continue to node to the second. You continue to execute. Okay. This is false. You come to statement 5, right? So so A is I, C is K, right? So you know if I want to execute the path I want to execute, this condition has to be false. So I connect one more branching condition, which is I has to be smaller than or equal to K. So far so good, right? And then we continue to statement 9. Statement 9 has to be true, right? In order to execute the path we want to execute. So at this point, B is what? B is J, C is K, so we know that B has to be greater than, J has to be greater than K, right? So we put, so again, I, J, K, they are external inputs, right? So I know, imagine I'm connecting the path condition, the branching condition. I know if I want to execute this path, I has to be smaller than or equal to J. I has to be smaller than equal to K, and J has to be greater than K. Okay. Then you're going to continue to execute. Now what is interesting here is that this condition is true, right? Then you have to execute the statement. So when you execute a statement, okay, remember that you only assign the values, okay, to the variables on the right hand side, not on the left hand side. Left hand you're going to assign 2, right? So inputs, the values that you have will only only the variables on the right hand side of the expression will be replaced with its value. So what this means is that you're going to basically execute these 3 statements. So to understand what we're doing is that if this condition is true, it means B greater than C, right? Remember we want to sort A, B, C, right? So you want to exchange the value of B and C. You want to make sure the value of B, you want to give the value of B to C and the value of C to B. That's basically what we are trying to do. Okay. So what we do here is that, say, you're going to first give the B's value to a temporary variable, and then you're going to assign C's value to B, and then you're going to assign the value of temporary variable to C. That's basically what you are doing, right? So that's, if you look at the statement we have here, you assign the value of B to a temporary variable, assign C's value to B, and temporary value to C, right? You exchange the values, these 2 variables. And if you do symbolic execution, you replace the variable on the right hand side, you're going to access its value, right? So the value of B would be what? When you come to this point, it's J, right? That's the value, the symbol you gave. Okay? What's the value of C? B, you do not change. On the left hand side, you do not change, right? Because you do not reference the value. That's an assignment. You have to understand how it executes, right? C, what is the value of C? It's K. And then you execute, you assign the value of T to C, which is basically what would be J, right? You assign J to T. So that's basically what you're going to execute, okay? So after you execute these 3 statements, Now you have to remember what is the value of A. Value of A is still I, right? What is the value of B? It's J. It's K now, okay? What's the value of J? So what's the value of C? Which is J. It's different, right? The reason now it's different because you have executed 3 statements. Okay? Now the relationship between internal variables and the external variables have to be changed. You have to do this. As we will see. Okay? Let's say then we finish this block, this if condition, we come to statement 13, right? Right? Because we want to execute 14, that means this condition has to be true, right? So then we're going to get this condition A plus B has to be less than or equal to C. If you to rewrite this condition in terms of the external inputs, what will be the condition? So you basically so now what is the value of A? It will be I, right? And what is the value of B? It will be K, right? It's no longer J. What's the value of C? J. So this is the condition you have to satisfy when you generate external inputs. Imagine if you do not execute these statements, if you come here, what are you going to get? You're going to get a different condition, right? You're going to get I plus J less than or equal to K. But that's not going to be correct. Does it make sense? The point I'm trying to say is that you have to execute the statements in order to get the correct branching condition. If you do not execute these statements, if you use this condition to generate inputs, you're not going to exercise the path you want to exercise. So symbolic execution does execute this statement, does try to perform the computations. But the difference is that you're not going to get the concrete values. You're trying to figure out the relationship between external inputs and internal inputs. As you know, I have chosen this example on purpose. It's very easy to understand how you're going to do the symbolic execution for this very simple assignment statements, right? When you have more complex statements, more complex data structure, that can be a challenge, right? For you to actually execute the statements without concrete values. Okay. So I can give you an example. Okay, let's say if B is an array, it points to a if B is an array, if you have an index variable I, okay, it points to a particular object. If you want to execute this statement, what are you going to put, right? What value you're going to put over here? Like here, it's very simple. B, the value of B is J. We know, right? But if you have a statement like this, what value do you put? We don't know, right? So what people do, you have to consider all possibilities. If the array has 100 objects, it could be any of the 100 objects, right? You have to try all of them. So you can create a lot of branches, okay? When the program gets big, because you have to consider a lot of possibilities, okay? When you do static analysis, when the program gets big, it's going to explode. That's the challenge of static analysis, because you do not know at compile time, you do not know the specific value. You have to consider all possible values. So again, I hope this example gives you some idea about the symbolic execution, okay, without get into the details of symbolic execution. Okay. But the basic idea is that it allows you to figure out the relationship between internal variables and external variables. Oops. I guess I stepped on the table.